A quiet landscape in Newell County, southern Alberta. Doesn't look like much, just an almost empty field, but this is one of the most innovative research sites in the world. Carbon capture and storage, or CCS, is an important part of Canada's clean tech sector with numerous career opportunities. This effective technology is being implemented by multiple industries, including manufacturing, agriculture, and of course, the energy industry, developing solutions to help reach the world's net zero emissions goals. Let's take a closer look at Carbon Management Canada's Newell County facility to see how CCS is changing the energy industry and innovating to improve the environmental impacts of greenhouse gas emissions. CCS includes the capture, transportation, storage, and monitoring of carbon dioxide, or CO2. Essentially, this is the process of capturing carbon and storing it in an underground reservoir to remove greenhouse gas emissions like CO2 from the atmosphere safely and efficiently. The field operator and geophysicists work to ensure the safe injection and secure storage of CO2 in the subsurface. The injection well is one of the most important pieces of equipment on site. Field operators inject CO2 into the reservoir. The minimum regulated depth is 1,000 meters. From here, you can get a better view of the entire facility.
Using injection wells like this one, Canada is currently capturing and safely storing millions of tons of CO2 per year. With technology like this, Canada is set to have a big impact on the reduction of global emissions. To help achieve a net zero scenario by 2050, we need to capture and store 5 gigatons of carbon dioxide.
Industries are implementing their own practices to capture their CO2 emissions and then transport them to storage facilities like this one. CO2 can be transported either by truck or pipeline. Once the trucks arrive, the tanker driver transfers the CO2 into the piping and stores it in the CO2 tank until the time comes to inject it into our well. This tank is a temporary storage container for CO2. It can hold up to 52 tons. The Newell Research Facility may look small, but it spreads out in all directions of the subsurface.
In addition to researching CO2 storage, this facility specializes in measurement, monitoring, and verification of sequestered carbon dioxide.
Field operators, data analysts, geophysicists, and reservoir engineers work to ensure that once it is injected, it stays where we put it. Observation wells are used by geophysicists and geologists for the continuous monitoring of the movement and behavior of CO2 within the subsurface, including potential leakage and migration. This monitoring allows operators to ensure that the CO2 remains contained within the underground reservoir. These passive monitoring geophones provide daily data for the geophysicists to track the CO2. Aside from general maintenance and occasional battery replacement, they are buried at a depth of 1.0 meters and provide a constant flow of data. CCS is a hub for constant innovation that will help the world reach its net zero emissions goals. Researchers from post-secondary institutions, industry partners, and companies from around the world use this facility. The research conducted includes new techniques for drone imaging, drone monitoring, digital monitoring, and new seismic imaging technology. There are numerous methods for monitoring the CO2 in the subsurface well. Geophysicists use fiber optic cable, 2D and 3D measurements, and seismic imaging to generate visual representations of the well and monitor the behavior of the CO2 in the reservoir. One of the best methods for monitoring the subsurface is through seismic imaging. The Vibrosis trucks, or Vibe trucks, are the facility's main energy source for seismic monitoring. The Vibe truck uses 15,000 pounds of energy to vibrate the ground, generating data for geophysicists to analyze. These vibrations send frequencies into the subsurface. The reflected waves are recorded using geophones or fiber optics to create a seismic image of the reservoir. Vibe operators use the Vibe truck around 250 meters away from the injection well, covering an area of 500 meters or more depending on the experiment. Vibe trucks are currently the easiest and most acceptable energy source for seismic surveys at the Newell County facility. The Vibe truck and its seismic imaging technology are the ultimate tools for telling geophysicists and the field operator what is happening in the subsurface. The bigger the truck, the more energy that goes into the ground, creating deeper waves and better data.